Right now, an AI agent is probably spinning up its own hidden hardware-isolated server on your network.
Yeah, completely autonomously.
Right. And it's negotiating security permissions with another bot running, I don't know, maybe 8 hours of complex data pipelines that it wrote itself and then just quietly shutting down.
And no one even notices.
Exactly.
Yeah.
The wild part is it's doing all of this without a single human knowing, let alone actually reviewing the code. So, welcome to the deep dive.
Glad to be here.
Just a quick fun fact before we jump in. Today's summary was actually generated using Notebook LM, but I want to be clear. Every single metric, release, and architectural shift we're about to discuss is strictly grounded in the actual public sources from a massive tech news update this week.
Yeah, the real data.
Right. And our mission today is pretty straightforward. If you're out there architecting cloud environments or locking down enterprise security or deploying, the next generation of machine learning models, your static blueprints are obsolete.
They really are. They're done.
We are tracking this massive architectural collision. The sources show that cloud infrastructure, cybersecurity boundaries, and AI development, they just aren't separate silos anymore.
No, they're actively merging into this single automated agentic ecosystem. It's a really profound structural shift.
Yep.
I mean, we're moving from a world where humans build the infrastructure to support the software to a world where the software dynamically provisions its own infrastructure just to complete a mission.
Which is kind of terrifying, but also amazing.
Right. And to really grasp the implications, we have to look at how the fundamental definition of, well, code and work is transforming.
Right. We have to look at what's actually being built.
Exactly. Then we'll get into how the raw cloud primitives are rebuilding themselves to survive this untrusted code, how identity models are evolving to police non-human traffic, and finally, the absolute limits of computational physics required to power it all.
Okay, so let's unpack that shift in how work is actually getting done, because the numbers coming out of OpenAI's new empirical research on their Codex agentic service are, honestly, they're completely jarring.
They really are.
We've spent the last few years thinking of LLMs as like conversational search engines, right? You put in a prompt, you get a snippet of code, you iterate. But it seems like that era is officially over.
Yeah, the data totally proves it. The heavy users, they aren't prompting anymore. They are orchestrating.
Right.
According to the research, over 25% of active tasks in these multi-agent workflows now exceed the equivalent of 8 hours of human labor.
Wait, a single task?
Yeah. And these power users are orchestrating up to 60 cumulative runtime hours daily across parallel agents. I mean, we're talking about long horizon autonomy here.
That is wild.
Yeah.
And it isn't just, senior software engineers doing this. The sources point out that non-developers, people in legal finance operations, they're successfully deploying these complex multi-stage data pipelines.
Yeah, which connects directly to that recent Kaggle white paper that's been making the rounds.
Oh, the one detailing the transition to what they're calling vibe coding.
Exactly. I know vibe coding sounds inherently chaotic.
It sounds like you're just hoping it works.
Right, but the architecture outlined in the Kaggle paper is actually a highly structured factory model. It documents this pivot from manual syntax-driven programming to intent-driven development.
Okay, so how does that work in practice?
Well, the human operator is no longer writing raw code line by line. Instead, they're defining the strict evaluation frameworks, the contact harnesses, the operational boundaries.
So they're building the guardrails.
Exactly. And then tools like Anti-Gravity 2.0 are used to corral these non-deterministic language models, basically forcing them to iterate internally until the output meets a very strict deterministic production spec.
So if I can use an analogy here, it's like the developer's job is shifting from being the line cook to being the executive chef.
I like that, yeah.
You aren't standing there chopping the onions or writing the Python loops anymore. You're writing the recipe, setting the absolute quality constraints at the pass, and rejecting the dish or, the test coverage if it doesn't match the specs.
So that's a perfect way to put it.
But here's where I hit a wall with this. If we have non-developers acting as executive chefs, using vibes and automated tools to generate millions of lines of complex, potentially hallucinated code every hour, where on earth do we actually run that safely?
That is the billion-dollar question.
Right, because we all know the blast radius of a shared kernel in standard container architecture. If an AI hallucinating an import statement pulls down a compromised library, it doesn't just crash its own task.
No, it can take down the whole cluster.
Exactly. The physics of our current cloud just can't support that level of untrusted nonstop execution.
And that structural vulnerability is exactly what forced AWS to rebuild their compute primitives this week. They just launched Lambda MicroVMs into general availability, and it's a direct response to this whole agentic wave.
Okay, so how are they isolating it?
They're utilizing Firecracker virtualization to provide dedicated hardware-level isolation for every single session, but they're delivering it with the near-instant startup speed of a serverless function.
Oh, wow. But AWS added a feature here that, to me, fundamentally breaks how we normally think about compute life cycles. These micro VMs can automatically suspend and resume.
Right.
They keep the memory in disk state completely intact for up to 8 hours. And each sandbox gets its own authenticated HTTPS endpoint for multi-tenant traffic over WebSockets or gRPC.
Yeah, it's a huge shift.
So an AI agent can spin up a server, crunch some data, pause itself, and wake up hours later to pick up exactly where it left off. But I have to push back on the economics of this.
Okay, what's your concern?
If an agent pauses its state for 8 hours, aren't we just creating a massive graveyard of zombie compute instances? Like, who is paying for the memory overhead of 1,000 paused agents sitting idle on an AWS rack?
Well, the economics are actually the most elegant part of the engineering here. When a Lambda MicroVM suspends, it isn't actually burning active RAM.
Wait, really? Where does it go?
AWS is utilizing rapid copy-on-write memory snapshots. They write the entire state to optimized, highly durable, cheap storage.
Oh,
So when the HTTPS endpoint receives a new request, it just pulls that snapshot back into active memory in milliseconds. You get the persistence of a dedicated server without paying for the idle compute cycles.
so the infrastructure just handles the orchestration dynamically.
Exactly.
That makes a lot of sense. And Microsoft is clearly feeling the same pressure for velocity, right?
Yeah.
Because their new Azure Landing Zone, or ALZ, Infrastructure as Code Accelerator, just hit general availability.
Yes, and the speed on that is incredible.
It cuts platform deployment down to about 12 minutes of interactive configuration. You get a foundational architecture built on Azure verified modules using native Bicep or Terraform across 11 out-of-the-box scenarios.
Yeah, 12 minutes is insane. And look at how data infrastructure is adapting to. Google just pushed BigQuery managed Python user-defined functions into general availability.
Which changes the game for AI data tasks.
Totally. Traditionally, if an AI agent needed to execute complex data science logic using NumPy or Pandas, it had to export the data, spin up a Spark cluster, run the math, and ingest it back. It was a whole process.
Very slow.
Right. Now, those Python functions run directly inside the standard SQL queries on fully managed serverless infrastructure.
But the mechanism Google is using there is critical for these AI workflows. They integrated Pyro for vectorized processing.
Yes, Pyro is the key there.
Because it processes data in contiguous memory columns, rather than scanning row by row, an AI agent analyzing millions of financial records doesn't suffer that massive overhead of data serialization.
Right. It just grabs the exact mathematical vector it needs.
And that results in a 10x throughput boost.
It's pure velocity. The infrastructure handles the compilation, the memory allocation, and the patching completely seamlessly, so the agent can just execute.
But wait, if you have an autonomous AI agent that can, pause itself, wake up 6 hours later and fire a high-speed Python query at an external enterprise API, how does the receiving network know it isn't dealing with a coordinated DDoS attack?
That is the exact problem we're facing now.
Because you can't put a traditional CAD-TCHA in front of an autonomous Python script. If the walls are moving this fast, identity becomes our single point of failure.
It absolutely does. When an entity hits your perimeter now, the primary question is no longer just, do you have the password?
Right.
It's, are you a legitimate human, an authorized enterprise agent, or a malicious scraper? And to solve this without completely breaking privacy, a massive coalition just announced CASCT private access control tokens.
Wow.
Yeah, it's a joint protocol from Cloudflare, Google, Microsoft, Mozilla, and Shopify.
But how does PanTT actually verify legitimacy without forcing some invasive tracking cookie onto the client?
It utilizes a zero-knowledge privacy architecture. So instead of tracking a user's IP or browsing history, trusted identity contexts like a secure device enclave or an authenticated browser session, they generate an anonymous cryptographic token.
Oh.
When the client makes a request, it presents this token. The enterprise network can cryptographically verify that the request comes from a trusted, non-malicious
It
source.
doesn't know who they are.
Exactly. The token itself contains zero identifiable data. It provides high integrity assurance to the network while completely blinding the external trackers.
Okay, so Passity acts as the bouncer at the club door confirming you aren't a threat. But what about internal traffic? Like, what if my enterprise network needs to specifically identify which internal AI agent is requesting access to a production database?
Yeah, that requires a much more granular architecture, which is why the Linux Foundation just introduced the Agent Name Service, or ANS.
Oh, this is huge.
They're basically establishing a federated identity standard by anchoring AI agent identities directly into the existing global domain name system, DNS.
So we're literally getting DNS for agents.
Yeah.
Instead of looking up an IP address, system operators can query the ANS registry to verify an agent's decentralized identifier.
Exactly. You can see what the agent represents, validate its specific permissions, and even ensure its underlying code hash matches the authorized version.
That's incredibly powerful.
And the brilliance of ANS is interoperability. By piggybacking on DNS, we don't have to build some proprietary siloed lookup network. Any system anywhere can verify an agent.
Right.
But, while the open source community is building this decentralized cryptographic trust, the major commercial AI labs, they are not waiting for a federated utopia. They're taking a brutally strict approach to liability.
Oh, you're talking about the Anthropic update.
Yeah.
They are rolling out a requirement where any flagged user account has to provide a physical, government-issued photo ID and a live selfie just to unlock their access.
Which is pretty intense.
Yeah, they're processing it through Persona, and if you fail the biometrics verification loop, it triggers a permanent, irreversible platform ban.
And the operational risk here for an enterprise architect is severe.
Oh, so.
Well, imagine if your primary CI/CD pipeline relies on Claude for code review via an API, right? And Anthropic's safety model suddenly flags the account for unusual multi-agent behavior.
Oh, wow.
Your automated pipeline doesn't just pause. It faces a sudden, hard block until a human physically submits a driver's license. It forces architects to build deeply robust multimodal failovers.
Which raises a sort of philosophical but highly practical point. We've got DNS registries for bots, zero-knowledge tokens for network access, and Anthropic is out here demanding a live selfie. Are we basically witnessing the death of anonymity on the internet just so our infrastructure can safely survive AI?
I wouldn't say anonymity is dying. It's being replaced by verified contexts. The system doesn't necessarily need your legal name, but it absolutely requires cryptographic proof of trust.
Right.
Because once an agent is verified, we are giving it unprecedented access to maneuver inside the enterprise.
Which means our traditional static defensive walls are entirely obsolete. I mean, if an agent is moving laterally through the network to complete a 60-hour task, defense has to become dynamic. We're entering the era of the agentic enterprise.
We really are, and defense is no longer just about detection. Just look at OpenAI's Daybreak initiative. They just launched GPT 5.5 Cyber specifically for verified defenders.
Yeah, the AI is actually taking action now.
Exactly. We are crossing the threshold from AI highlighting a vulnerability to AI autonomously patching it at machine speed.
And the performance metrics on that are wild. On the CyberGem benchmark, GPT 5.5 Cyber outperformed Claude Mythos 5, hitting an 85.6% success rate.
That's a massive jump.
It is, but the real game changer is the Codex security plugin they released in research preview. It doesn't just scan code, it actively builds code-based specific threat models, validates reachability to see if an attacker can actually trigger the flaw.
Which is huge for reducing false positives.
Right. It traces the execution paths and then auto-generates contextual code patches.
But, you can't simply unleash an autonomous patching agent into your production code base without a governing architecture. You need a framework that evaluates context at every single step.
So how do you govern it?
That is exactly why CESA just released their vital new guidance on integrating Secure Access Service Edge, SACE, within the Trusted Internet Connections 3.0 framework.
Okay, so how does SACE actually solve the problem of autonomous agents interacting with distributed assets?
Well, SACE fundamentally moves the security perimeter from a centralized VPN choke point out to the distributed edge. It converges networking and security into a single identity-aware proxy.
Okay, I follow.
So when a Daybreak agent attempts to push a patch to a cloud-hosted database, the SACE architecture doesn't just look at the IP. It evaluates the agent's ANS identity, the PayCT token, the device posture, and the specific resource sensitivity in real time before granting access.
Wow.
It is the architectural manifestation of zero trust.
And these agents aren't just sitting around waiting for instructions anymore either. They are actively seeking out the tools they need. The industry just launched the Agentic Resource Discovery Specification, or ARD.
Yeah, ARD is going to change how agents interact.
It's this new open standard that relies on machine-readable JSON catalogs, specifically an iCatalog.json file hosted on a domain.
It abstracts the entire discovery process. So instead of a human hard-coding API endpoints into an agent, the agent can dynamically crawl these JSON files to find model context protocol servers or functional APIs completely on its own.
Just discovering its own tools.
Exactly. And because ARD integrates cryptographic trust metadata directly into the JSON, the enterprise environment can validate the publisher's authenticity before the agent ever even initiates a connection.
So ARD is essentially a decentralized registry for agent capabilities. But what happens to all the data these agents accumulate while they're discovering tools and patching systems?
That's a major storage and security issue.
Right. Amazon just addressed this by pushing Bedrock Agent Core memory into general availability with cross-account access.
The architectural decoupling here is absolutely crucial. Previously, an agent's conversational memory and its context window were tightly bound to its runtime environment.
Which is risky.
Very. Bedrock allows developers to completely decouple that long-term memory. The agent becomes stateless, while the memory payloads stream directly into dedicated, secured S3 buckets in completely separate AWS accounts.
So if a specific runtime agent gets compromised, or if it just hallucinates, the attacker doesn't inherit the entire corporate memory bank.
Exactly, because the memory relies on cross-account IAM policies.
The agent just queries the Amazon resource name, the ARN, to perform semantic vector searches.
Yep.
Okay, so looking at the board here, ARD lets agents discover each other dynamically, Bedrock gives them a decentralized, persistent memory, and Daybreak allows them to autonomously rewrite our code.
It's all coming together.
But if an AI agent negotiates access with another AI agent to patch our infrastructure, what is the human security architect actually doing? Are we just spectators at this point?
No, the architect's role just elevates. It goes from managing configurations to managing systemic risk. You aren't checking the lock on the door anymore.
You're designing the building.
That's right. Your job is to design the cryptographic trust policies, configure the SASE edge routing, and set the blast radius constraints. The agents execute the tactics, but the human defines the physics of the environment they operate in.
That makes sense. But, I mean, to power an environment where thousands of agents are constantly searching, patching, and verifying cryptographic tokens, the compute overhead must be absolutely paralyzing.
It's massive.
We aren't just parsing text anymore, which brings us to the hardware frontier. Google just pushed a developer preview of native computer use in Gemini 3.5 Flash. We're moving from niche, single-purpose automation scripts to a massive multimodal LLM that can natively see, reason, and act across browser, mobile, and desktop operating systems.
But letting an LLM autonomously click around a desktop environment is an immense security risk.
Oh, for sure.
To mitigate this, Google had to build in targeted adversarial training and indirect prompt injection detection at the model layer.
How does that protect it?
Well, if a hidden prompt on a website tells Gemini to delete a local directory, the model is actually trained to recognize the context switch. It'll pause for mandatory human-in-the-loop validation before doing anything irreversible.
That's smart. Meanwhile, Microsoft Foundry just hit GA with Mistral Document AI featuring OCR4 alongside Mistral Medium 3.5.
Yeah, that's a big release for enterprise.
Document AI is bringing true structured ingestion. We're talking paragraph-level bounding boxes and block classification. But the release of Mistral Medium 3.5 is what really caught my eye. It's a 128 billion parameter-dense model with a 256K context window.
It's a beast.
But why does an enterprise need to run a 128 billion parameter model on their own hardware instead of just calling the OpenAI API?
It all comes down to data residency and regulatory compliance. If you're a defense contractor or a healthcare provider, you legally cannot send highly sensitive, unstructured data over an API to a centralized cloud provider.
Right.
You need the open weight flexibility of a model like Mistral. You download the weights, deploy it inside your own air-gapped Azure landing zone, and execute complex reasoning tasks entirely within your own strict audited boundaries.
But as these localized dense models scale up, We are rapidly hitting the ceiling of classical computing.
We really are.
And the Cloud Security Alliance just published a paper on the looming feedback loop between quantum computing and artificial intelligence.
This synergy between the two is exactly what will break the current compute bottlenecks.
How do they help each other?
Well, quantum computing struggles with decoherence. The qubits are inherently unstable, they're prone to environmental noise, but AI neural networks are incredibly efficient at pattern recognition.
No, I see where this is going.
Yeah, we are seeing AI used to map those error patterns in real time, actively stabilizing the logical qubits. And in return, those stabilized quantum computers will be able to run complex optimization algorithms that drastically accelerate AI parameter tuning and training phases.
It's just this unimaginable feedback loop of compute power. But perhaps the most surprising hardware pivot this week comes from Midjourney.
Oh yeah, this is fascinating.
The generative art company has launched Midjourney Medical to pioneer full-body ultrasonic computational tomography. They are transitioning from generative software to massive sensor-driven hardware.
And the sheer physics of this project is staggering. They're prototyping a system with roughly 358,000 individual transducer elements,
Wow.
all firing and recording acoustic data simultaneously. Because sound waves bounce unpredictably through human tissue, the system requires over 2 petaflops of computing power across 21 servers just to capture and process 17 gigabytes of raw acoustic data every single second.
Midjourney going from generating pictures of astronauts to mapping human tissue with 17 gigs of raw acoustic data a second is wild.
It's a massive pivot.
But here is the critical detail for AI architects. To reconstruct that data, they are using mathematically rigorous inverse scattering algorithms. They are explicitly refusing to use generative models.
Which is key for medical tech.
Right. The neural networks are restricted purely to deterministic 3D reconstruction. It highlights a vital lesson for the enterprise. When you're dealing with human biology or core enterprise infrastructure, you cannot tolerate generative hallucinations.
No, absolutely not.
You need deterministic mathematical truth.
And that principle anchors everything we've discussed today. The industry is no longer just building software tools, it's provisioning a highly complex digital workforce.
Yeah.
From the AWS MicroVMs providing the secure physical space, to ANS and Packet establishing the cryptographic trust, to Gemini independently navigating interfaces. The old silos of cloud, security, and AI have dissolved into one continuous, intelligent fabric.
The blueprint is really drawing itself at this point. If you want to keep your finger on the pulse of these massive shifts, make sure you follow the show Cloud Cybersecurity News on Spotify for more deep dives into cloud, security, and AI insights.
Definitely. The pace of integration is only going to accelerate from here. The frameworks we unpacked today, ANS, ARD, SASEs, MicroVMs, these are the absolute foundational pillars of the next decade of enterprise architecture.
Which leaves us with a final thought to mull over. We've talked about AI agents orchestrating 60 hours of autonomous work, dynamically discovering APIs through JSON catalogs, and securely patching vulnerabilities. You have to wonder, when an AI agent dynamically discovers another AI agent, negotiates permissions via a decentralized DNS, and writes its own hardware-isolated micro-VM to execute an 8-hour task perfectly, at what point does the human architect transition from being the creator of the system to simply being a spectator of their own infrastructure? Something to think about. Until next time, keep exploring.